All right, picking up where we left off, we were getting ready to graph exponential functions. Now, keep in mind that I do not have a TI-84 emulator on my computer at home, so I am using the Desmos graphing calculator right now. So try to follow along with what I'm doing on the computer on your own calculator so you can make sure you have the process down. If you need help with your calculator, please let me know. I'm more than happy to try to figure out a way to help you. I just can't demonstrate in the exact same software, okay? Now, the very first graph it wants us to look at in our calculator is 1.2 to the x. So I'm going to type this in here, and there we go. Voila, we've got our first graph. We can see that it is increasing. It still has that same y-intercept of 0, 1. It also has a horizontal asymptote at y equals 0 still. Okay. The next one is f of x equals 0.8 to the x. Notice that this one's actually decreasing now, but it still has that same y-intercept of 0, 1. Still has that horizontal asymptote at y equals 0. This next one is 0.99 to the x. Now, when we first see this one on the window that's given, it almost looks like a flat line. And you might be experiencing this on your own calculator as well. You may want to zoom out several times and change that window. If I zoom out here, we're going to see that I do get that same shape. This one is decreasing. If I zoom back in, we can see that it does still go through that 0.01, and it still has a horizontal asymptote at y equals 0. Okay, and my last one is 10 to the x. We're going to zoom back in on this one. So remember that if you need to reset your window, you can do that with Zoom 6. That's your Zoom standard window. So go back to that original window if you played around with it in the previous one. So here's 10 to the x. Again, we're seeing that it has a y-intercept still of 0, 1. This one's increasing, still has that horizontal asymptote at y equals 0. Okay, let me switch back over to our PowerPoint. Like I mentioned before, if you have any questions on your own calculator with those graphs, please let me know. I'm happy to figure out a way to help you. Okay. Now, if we think back to those graphs that we just looked at, as well as some of the graphs we've already seen, the two that we did by hand with the chart, what is it that determines whether an exponential function is increasing or decreasing? So we're looking at f of x equals a to the x. What is it that determines whether this is increasing or decreasing? It's all about that a value. If a is greater than 1, it's going to be increasing. If a is less than 1, it's going to be decreasing. And we've mentioned a couple other good properties of exponential functions that are good to know. My y-intercept in general is that 0.01. And again, generally speaking, we're going to have a horizontal asymptote at y equals 0. Now, we previously looked at transformations. We did these with our parent functions, and we're going to do them with exponential functions as well. So keep in mind that these general properties we're talking about right now, they will shift as my graphs start to shift as well. But these are good reference points to start out with for any basic exponential function. So, transformations. We've looked at the function f of x equals 2 to the x. It was that first one that we graphed and we made a table of values for it. Now we need to think about how would the graph of g of x equals 2 to the negative x compare to f of x. So think about what's happening here. I have a negative x in my exponent. This is going to reflect my graph over the y-axis. So now, this graph that was previously increasing, this is a quick sketch of 2 to the x, if it flips over the y-axis, 2 to the negative x is now going to look like this instead. So start with that basic foundation and then use that reflection. What about the graph of g of x equals 2 to the x minus 3? This x minus 3, if it helps you visualize this, we can think of this in parentheses in our exponent, is going to move my graph to the right 3. Very similar to before, really the same as before. If it's inside, it's going to move horizontally left and right, the opposite of the sign as you would expect. So this one's going to move to the right 3. So think about what this means. My previous function, 2 to the x, that went through that point 0, 1, if I move it 3 to the right now, I am now going to have not the point 0, 1, but instead I'm going to have the point, oh, I just lost my graph. Sorry, quick restart for myself. We had 0, 1, over 0, up 1. Now we're moving this graph to the right 3. So that point 0, 1 is going to become the point 3, 1. So we can use that initial reference point as a guidance in how we're going to transform that graph. All right, let's talk about how would the graph of g of x equals 2 to the x plus 4 compare to f of x. So realize now that this plus 4 is not in my exponent. It's going to affect it just like all my other previous parent functions. If I add 4 to it after the fact, that means that this is going to move it up 4. So what this means for my horizontal asymptote and that point is that now when I move that up 4, my horizontal asymptote is no longer at y equals 0. It's now at y equals 4. That point 0, 1, if I move it up 4, is now going to be at 0, 5. So this was 0, 1. I moved it up 4. It ends up now at 0, 5. So realize that as I move my graphs up and down, it's important to remember that your asymptote will change. All right, now we've got g of x equals negative 2 to the x. When I have that negative in the very front, it flips it over the x-axis. Just like that comparison to our parabola, that negative in the front flips my parabola downward over the x-axis. Okay, So previously, we had something like this. If we flip it over our x-axis, we are now going to get this. Notice that my horizontal asymptote does not move. It stays at y equals 0. But that point 0, 1 is now 0, negative 1. All right, next up, we want to talk about how the graph of g of x equals 2 to the negative x plus 3, all in that exponent, how that compares to my original graph of f of x equals 2 to the x. We've got two things going on here. We have a flip over the y-axis, and we have a horizontal shift, okay? Now, keep in mind, this is the same as writing 2 to the negative x minus 3. This means that I'm going to have a reflection over the y-axis. It also means that I'm going to shift to the right 3. Okay, so I'm reflecting over the y-axis and I'm moving to the right 3. Now, if we think about this, here's my original graph. I now am going to reflect this over the y-axis, and I'm going to shift it to the right 3. So after that reflection, I still have 0, 1, but now that point is going to move to 3, 1. Notice that in this situation, did my horizontal asymptote change? No, it still stayed y equals 0. Only time that horizontal asymptote is going to change is if I move my whole graph up or if I move that whole graph down. All right, let's try one more graphing problem. And this one's going to start out by asking me what is the y-intercept for f of x equals 5 times 2 to the x. Now, keep in mind, y-intercept, we have to write it as a point because it's an intercept. But also, to find the y-intercept, we plug in 0 for x. Plug in 0 for x. So that means we are going to have 5 times 2 to the 0. Follow your order of operations. Exponent first. 2 to the 0 is 1. So this becomes 5 times 1, which is 5. So that point, my y-intercept is the point 0, 5. Be very careful to follow your order of operations on these kinds of problems. Exponents first. Okay, so let's take that point and let's use it to draw a rough sketch of what this graph is going to look like. We know we have the point 0, 5. 1, 2, 3, 4, 5. There's my y-intercept. Okay. Think about this. Is this graph going to be increasing or is it going to be decreasing? That base value is greater than 1, so it is going to be increasing. And we also need to make sure that we mark our asymptote. This graph does not move up or down, so my asymptote is going to stay right here at y equals 0. Okay. I need one other point. We can pick any point we want. You can use your calculator to help you with this, or we can plug in a number. Let's plug in 1. 1's easy to plug in. 5 times 2 to the first. Again, order of operations, we're going to do 2 to the first. So 5 times 2, which would give us 10. So this would give me the point 110. So let's see, we'll go over 1, 5, 6, 7, 8, 9, 10. This is just a rough sketch, but we would have the following shape. There we go.